Hello everyone. I hope all of you have been able to download sp500.csv dataset. I'm going to use the read_csv function and pass as argument sp500.csv string, which is the relative path to the CSV file. Let me capture the return value into a variable called df, and I'm going to invoke the head function call on the data frame df. This particular dataset contains two different columns. The first one is going to be the year column, which starts at 1970. The second one is going to be the return column, which indicates the gain or loss along with the dividends that you obtain for investing in the SP500 index for that particular year. SP500 index is the price index for top 500 US companies. It is not the stock price for individual companies in the top 500 list. It is rather index pricing. What we are going to now go through here is this analysis question, which is asking how much current wealth in 2021 would we have if we had invested $1,000 in 1970. Here is a basic aspect about money management. When you double your money and triple your doubled money, you're going to end up multiplying your initial money by 2 and by 3 in order to obtain your recent gain, correct? That's what we are going to apply to solve this particular question. We are going to learn about Comprod function, which works on a series. I'm first of all going to extract the return column as a series here by typing df of return. I can call the Comprod function on this series by typing .comprod. That's going to produce a brand new series. The first value in the new series is going to have the same value in the original series because you don't have any prior values to multiply that by. The second value is going to come from multiplying value number 1 and value number 2. Third value is going to come from multiplying value 1, value 2 and value 3 and so on. Let me capture this cumulative product series using a column called total within the data frame df. I'm going to do that by typing df of total equal to this column. Let me go ahead and display the head function call output. Observe that we were able to insert that particular column. Let's take into consideration the initial investment, which I want to define as a variable start here. I'm going to compute a new column which I want to name as wealth. Wealth column is simply going to be df of total into the initial investment, which is going to be the start variable over here. Let me go ahead and display the tail of the data frame df this time. Observe that if we had invested $1,000 in 1970, we would have ended up with 200,000 plus dollars if we had sustained the investment for such a long time until the current year, which is going to be 2021. Let's take the wealth column and create a line plot for it. I'm going to do that by first of all extracting the wealth column by saying df of wealth. This is going to extract a column series. So if I say plot dot line, that's going to produce a single line plot because you have a series over here. Couple of issues with this plot. The x-axis has meaningless labels which are coming from the data frame row index. Recall that you can use the set underscore index function within a data frame by typing df.set underscore index. What do we want to set as the index here? That's going to be the year column because your x-axis here is going to represent various years during which you have sustained your investment. We need to capture this particular return value into the same variable df because the set underscore index function returns a brand new data frame object instance. What else is wrong with this plot? It does not have a y-axis label. Let me go ahead and capture the axis subplot object instance from the return value of the plot.line function. I'm going to use set underscore y label function in order to set the y-axis label. I want to set the y-axis label as wealth in dollars over here. Let me go ahead and execute the updated version of the code cell. Observe that we are getting proper x-axis values and y label here. I'll wrap up this example here. We are going to continue this example at the beginning of the next lecture. That will be it for today's lecture.